I really hope that you enjoy the workshop, and I'll be here monitoring the chat. So again, any questions, comments, just type it there. And now I'm going to hand over the mic to Eric and go on mute. Thank you.
Okay, I'm going to do a screen share now for everyone, so I'm going to go away for a moment. Thanks for the introduction, Claudia. Eric Rodriguez. I am the Director of Horticulture for Friends of the Highline, and have had the privilege and pleasure of working with GreenThumb on a few projects over the years. And I'm going to be chatting with you today for about 40 minutes on how to build and manage a community seed library. Just a quick overview of some of today's topics. We'll be talking about what seeds are and why seeds are important. We'll come to a working definition of what a community seed library is. We'll be chatting about who organizes a seed library and who benefits from that work directly. We'll also talk about how to define seed library objectives and goals and the importance between making a distinction between objectives and goals in community activist projects. We'll also be talking about how to scale a project up and how to scale a project down sustainably. We'll also talk about, and this is more the botanical aspect of things, hybrids, open pollination, and heirloom plants, particularly heirloom vegetable crops. We'll talk about some key definitions, mostly around plant reproduction, plant pollination, and some concepts of storing seeds and different storage needs for different species of seeds. And then we'll leave about 15 minutes at the end for audience questions and answers, and hopefully I have some answers. And if not, then I definitely have some places to refer you. And just the one caveat for the whole thing is that this is a really fast crash course on some very big topics like plant genetics, plant breeding, um, botany, biology, intellectual property law, and community engagement. So it's very brief overviews over all of those things. But my goal in putting this together was that I give you just enough of an introduction to all of these topics that you can go off and do independent research and not get lost in the figurative weeds on these subjects. And you have some baseline for working through those concepts. So to kick off, what are seeds? Besides being absolute magic, seeds are embryonic, or stated more plainly, baby plants. In each seed is living, breathing, alive, feeding plant that's just waiting for environmental cues to germinate, to start growing outward. And these environmental cues typically are things like changes in temperature, changes in moisture, changes in sunlight. So when you start a seed, you're tricking it or encouraging it is say that this is the ideal time for it to start growing. Um, Seeds are produced by the dominant form of plant life on Earth. And what I mean by that is, of all of the species that exist on Earth, the largest, most dominant form in terms of sheer representation of plant life are plants that produce seeds, which part of the reason is there's a lot of genetic diversity that happen through seeds, and we'll talk about some of that later. But just to distinguish between things like ferns, which produce spores and don't produce seeds, plants that produce seeds outrepresents those forms of plant life. Um, Seeds are often edible. We eat a lot of seeds in our daily diets, except when they are very, very toxic. And that's the other caveat of seeds as well. From an evolutionary perspective, it makes a lot of sense for a seed to be toxic if you don't want something to eat you, unless you have co-evolved with a particular animal to be eaten and then have your seeds carried off and distributed elsewhere. And we'll talk about that a little bit later as well. And seeds also, as I noted, besides containing baby plants, there's plant food and nutrients for that plant to eat and survive while it's in its dormancy. And that's typically what provides nutrients for us as well. It's called the endosperm. It also provides nutrients for that plant, but When we start talking about the viability of a seed, which means how long a seed can stay in dormancy before it exhausts its food source, that is more or less what we're talking about. So why are seeds worth saving? Seeds are worth saving to promote social and cultural food traditions and food sovereignty. We have strong attachments to our food. We engage in culinary traditions ourselves better and the world around us and other people. And particularly these days, there's an increased interest in understanding where your food comes from, how your food is grown, the invisible hands that touch your food, the politics of food, and safety around food, and particularly safety for those who are growing food. Saving seeds helps us engage in those larger socio-political conversations. From an ecological environmental perspective, seeds protect genetic biodiversity. And it helps us to avoid monoculture. Well, the idea that a healthy community is a community of diversity, both in people and in plants. These are goals that we want to encourage through seed saving. Um, Seeds are also worthwhile for helping plants to changes because of climate, to develop better resistance and disease, and to be able to deal with adverse weather conditions, to be able to evolve. And so when we're talking about plants being able to adapt to changing conditions, we are talking about the resilience of plants. And seed later as well, but a lot of food crops that we get in supermarkets and that are readily available have been bred to withstand long-term refrigeration, storage, being shipped across the country, being able to withstand bruising and handling. And as a part of that breeding to get those characteristics, we have oftentimes bred out a lot of nutritional value and flavor in food crops. And so, for those of you who are interested in heirloom plants and particularly food that's flavorful, seed saving gives you a lot of access to things that you otherwise wouldn't necessarily be able to get access to in a conventional supermarket. Community seed library. It's a question I am constantly asking myself. And the basic working definitions that I've come up with in conversations with other people are they're activist civic science projects. What I mean by that is they're typically led by volunteers who actively care around biodiversity, saving plants, and connecting with other people. But the underlying theme of all of it is that people really care. And whatever their intersection with a community seed library is, it's because they have chosen to take the time and make the effort to do something as a labor of love. Um, Community seed libraries are intended to be self-perpetuating and resilient. And what I mean by that is they're intended to be projects that continue as opposed to just being a one-time thing. And so when you're thinking through resiliency in planning a community seed library project, some different ways you can think about it, that resiliency can be through an economic lens, the material costs of running a seed library, through an environmental lens, how resilient the plants are, the seeds are that you're saving, and the social resiliency of it is how a community seed library can be used to foster closer community connections and make the place you live a better place, not just for your generation, but the subsequent generations to follow. And seeds are collected for years to come, meaning you grow seeds out in one year and they're intended to be planted out the following year or many years after that. Um, and very similar to lottery books and things being in circulation, seeds go out and seeds come back into the library. Um, and that's an important distinction to make between a seed library versus a seed distribution project. Um, the objectives of why you're trying to create a seed library really more about keeping things in circulation as opposed to a seed distribution project. We're really about giving out seeds. But we'll go more into the sustainability of projects in just a wee bit. So clarity and accountability around an activist community seed library project. Um, the question of we in an activist civic science community seed library project should be easier to answer than who community is. And this is a very big way of saying it boils down, in my mind, to two essential questions. We, as in who is going to be doing the work of running and organizing a community seed library? And in terms of community, who is going to receive the benefits of this work? And so I encourage people when they're planning community seed libraries to always go through a reiterative process of who is going to actually be doing the work and who is going to receive the benefits of the work. And this, both definitions and the answers to both of these questions will probably shift over time. And if you're constantly evaluating the project, they should shift over time. Um, I find that there is a common theme around activist community seed library projects where everybody is really, really excited to do them. And this is a beautiful thing. You always want to hold on to that excitement and that momentum. But I think a lot of people sometimes become disillusioned in that community activist projects because there may be a miscommunication with different people involved around the critical definitions of who is in this context of who is going to be doing the work and the community aspect of it of who is going to receive the benefits of this work. In a community seed library project. Projects should be thought of in terms of both objectives and goals. And I think oftentimes these two terms can be used interchangeably. And I would encourage you all to be very specific about defining both objectives and goals. And I think a good framework for thinking through that for a seed library project is objectives describe why things are happening. They should be aspirational and they should think about the big picture of the entire activist project. Whereas goals describe how things are happening. Uh, it's easiest to define in specifics of seed distribution. What I mean by that is goals should be measurements of success. So this way, everybody who's participating in the project understands clearly what the work is about and what defines the success of the work across the entire activist project. So I drafted some for a community seed project once that I now that I think defines the two concepts. So in this case, the objective was we are starting a community seed library to gain food sovereignty, increase biodiversity in our neighborhood, and promote environmental sustainability. Very big picture, very zoom out. It's a lovely, good objectives are feel good. They should leave you feeling inspired by a project. But it's important to understand how the project is actually going to happen. And so this is where it gets more to the measurable goal of the project. And in this case, the project's goal was we will distribute 100 varieties of culturally appropriate food crop seeds to 2,000 residents of Harlem in year one of the project. It's very, very specific about what defines success in this project and what they're going to be doing in year one. And that'll be really important when we get to later on in the presentation and talk about scaling up or possibly scaling down a project from year one to year two or in subsequent years to make sure that the project is self-sustaining and resilient. When we're talking about scale, we're talking essentially about the size of a project. A community seed library can be as small scale as a shoebox or as large scale as a whole building and everything in between. I have built community seed libraries where I've had 500 accessions in a shoebox. It is possible, and in a very small shoebox. I've also have worked with grants and museums to build climate controlled seed libraries that have actually had fewer accessions than that. So scale can talk more to what the goals are of the project than necessarily the number of seeds that you have in the library. Because again, we're focusing more on the community engagement part of a community seed library. So projects can start small and scale up in terms of their goals. And that's to say, what are the measurements of success for year one versus year two versus year three? And if an activist project is healthy and people are engaged, and it's thought through sustainably, both in terms of the cost and the labor of the people involved, you can think through a community seed project through multiple years. Seed libraries with measurable goals are more likely to self-perpetuate, meaning that they can continue going. The original founders or members of that project rotate out, and I encourage people to design activist projects where multiple people can inherit the work and they don't live with individuals forever and ever, because projects do need to evolve, and that is the definition of community, I think. Seed distribution projects don't need to self-perpetuate. Again, we were talking about seed distribution projects where you just give away seeds, necessarily come back. So in this case, they don't have to keep going and going, and they don't need goals in quite the same way. You don't need to measure success. If your goal is to give away a bunch of seeds, then you can do that really easily. But this is where the community aspect of who is going to benefit directly from the work is really more important. Community in terms of having impact through a seed distribution project um, tends to be more impactful through a lens of goals, through measurement. In continuing and talk about the we component, who will do the work, there are some real critical questions that I find are really useful for helping people have conversations around how to build a community seed library. How small is the project itself, to be defined by the members and activists in that project? How many people are we trying to give seeds to? Um, do we want to people, sorry, do we go to people who want seeds, or do they come to us, or both? Does the library travel? And this, I think, is for people who are creative and people who are exploring sewing right now. I've had a dream that people will build community seed libraries out of articles of clothing, because if you can sew a pocket into something, you can have a traveling community seed library. But in terms of how you engage people and where you meet them and where you define community, your library may not exist only in one place. It might end up being a traveling library. You can also have a community seed library via mail, which is much more of a pen pal model. But just to say that seeds do travel, and that is kind of the point of them. Said, it is important to understand where the seed library physically is going to live. Those seeds do exist in physical space. And so while the information around the activist component of it can be virtual, you have a website, you can have a flyer, you can have board sign or an A-frame in your community garden, and somebody doesn't need to physically be there. The actual library component of the seeds does need to be physically where it lives, because again, seeds are living things, and you have to think through how to keep those little seeds dormant and in healthy condition, so when you distribute the seeds out, they're likely to grow. Some more questions to consider around scale. Who will be able to access the library and the seeds directly? And who won't be able to access the seeds directly? And this is really more about the people who are keeping the seeds and running the project as volunteers, as opposed to community members who will be receiving the seeds. Um, those volunteers who are running the seed library should consider themselves the gatekeepers of the integrity of the stock of the seeds, to make sure that they're stored properly, that they don't go moldy, they don't get eaten by rodents, etc. Because it goes to the heart of the sustainability of the project for one and in year two and the subsequent years. How many kinds of varieties, cultivars, and species are you distributing and growing? And how do you make a decision about it? How do you decide? You can't do it all. This is a time when everybody is searching through seed catalogs and is really excited to grow seedlings. And you want to collect them all, and I encourage people to keep that in their hearts. But from a practical perspective, you can't collect them all, and you can't grow them out all. And again, seed libraries, particularly activist seed libraries, if you're considering the ecological sustainability of it, you want to keep that genetic material in circulation as opposed to just being stored away forever and ever because you want these plants to be able to evolve from one plant generation to the following plant generation to the one after that. How much time can we commit to this project? Oftentimes, by definition, although not all of them, some do pay volunteers. But by and large, again, because these are laborers of love, people are donating their time. And so we have to be mindful about how much time people can actually commit to it and be forgiving with people when life gets in the way and they may not be able to participate as much as they have in the past, or if they can't participate as much as some other people in the ACT project can. Um, how many people do we need to run this project? If you're talking about distributing 2,000 seed envelopes in a year, you're obviously going to need a lot more people than if you just decide to distribute 20. And so that goes to the heart of scale and what the goals are for the project. Uh, so now we're going to talk about some seed saving basics. F1 hybrids. As you're looking through nursery catalogs now and seed catalogs now, or some of your own seed envelopes, you might notice that on the packaging, you'll see something that says F1 hybrids or F1 cultivars. And the way we can think about this very simply is the parents and the kids, parent plants and their seed offspring, and the plants that grow from those seeds as the kids. And what an F1 hybrid is, and I'm going to use a tomato metaphor for this because I am a really avid tomato collector and seed propagator for tomatoes. So for those of you who like heirloom tomatoes, two of my favorites are Black Krim and Paul Robeson. Both are both purple brown tomatoes. Um, Let's say you have one parent is Black Krim and you have another parent that's Paul Robeson. If you cross those two together, the kids that would grow from those seeds that were collected from the fruit of that cross is the F1 hybrid. And so when you cross two parents together that have different characteristics, you're playing a bit of a guessing game in terms of um, what those kids are going to look like and what their characteristics are going to be. Um, it's not so uncommon in people that their kids are very different from the parents that raise them. And it's very similar in plants as well. So this is just to distinguish between something we'll be talking about later on about open pollinated seeds. Um, and so why are F1 hybrids something to talk about? Because it is very difficult to save seeds from F1 hybrids. Not that you can't save seeds and start seeds. It's just that if you're talking about preservation of particular kinds of species or particular types of heirloom plants, particular varieties, you're playing a bit of a guess because you don't know what the original parent stock of those plants were. Um, that said, a lot of people prefer to grow F1 hybrids because, and F1, by the way, stands for first filial, which is a very fancy way of saying the first generation of kid plants that developed from the seeds that were saved from the parents that were crossed together. Um, so a lot of people talk about hybrid vigor in plants. And this is a concept that is sometimes true, except in all the instances where it's not, where if you cross two different varieties with different characteristics together, you'll get offspring that is more vigorous or is more resilient to certain things than other things. Oftentimes, you'll see that in terms of disease resistance or the ability to withstand insect damage. And this is just to say that of seeds that are introduced that are F1 varieties that are said to have hybrid vigor, it's because people have specifically selected those crosses to produce offspring plants and offspring seeds that demonstrate that. So you could have 100 plants, 25 of those may demonstrate hybrid vigor, but 75% may not actually, and may actually perform poorer than either of the two parents if you grew them out in a field. Um, and something we talked about earlier in monoculture, if our goal is to increase biodiversity, one of the things that happens with F1 hybrids is they're oftentimes grown to be able to standardize certain things, particularly in practices. If you're running a tractor and you want to harvest everything at the same time, using one piece of machinery, one attachment for that tractor, it makes a lot of sense to standardize the crop that you're growing. If you only want to be able to store things in cold refrigeration trucks and ship them across the country, or you want predictability about how something is going to grow in the field, you standardize. And one of the easiest ways to do this is through F1 hybrids. You're controlling a lot of the variables. But the trade-off of that is you're creating a monoculture, which means that you're reducing the biodiversity of those crops, or of other plants or other species that you're growing. And lastly, but not leastly, and this is a really important factor when you're talking about the ability to save seeds and who quote unquote owns seeds, we're talking about a lot of F1 hybrids are registered trademarks, or there are royalties that you have to pay in order to use their name in print. Some plants are actually patented through the US Patent Office, which means that they've paid a lot of money to restrict people's ability to access it and to sell it or to distribute it. And so, in order to be able to save seeds from those and distribute them, even for free, you have to ask for permission or you have to pay a royalty in order to use them. Which then takes us to the concept of open pollinated seeds. Seeds that are open pollinated are said to breed true, which means that the offspring from the seeds of the parent plants will be very similar in characteristics to the parent plant. So again, using the black crim tomato model, if I cross two black crim plants together, they will produce seeds that will produce plants that are very, very similar, if not identical, to the original black crim tomato parents. So if they're pollinated by an individual of the same variety, the seeds will be very, very similar to the parent generation. And so when we're talking about that concept, we're talking about standard varieties, and you'll see this come up in plant propagation and in seed catalogs. That means that those characteristics have stabilized themselves over a long period of time. And so seed savers can say fairly definitively that when I grow this thing out, I know what I'm going to get, and the expectations will line up in the end. Open pollinated seeds in this case, again, will come true from seeds, whereas F1 hybrids, because you're hybridizing different characteristics from different parents, if you save seeds from them, you may get, when you plant those seeds out, you may get things that look very, very different from their original parent plant, which is not a bad thing. This is also a way for biodiversity to happen. Infinite combinations lead to infinite outcomes, which can be really great for a seed library, particularly when community members are bringing things back. But the trade-off of that is it's less predictable. So when you distribute seeds out, you don't necessarily know what you're distributing out. But I encourage people to try to play around with F1 hybrids because you never know what you're going to get, and you might be able to make a new introduction for open pollinated seeds. Also, there are seed savers who like to play around with F1 hybrids and try to figure out what the magic recipe is to create an open pollinated variety that doesn't have intellectual property attached to that. And so there's a food sovereignty issue that's in play with that as well. So a lot of people really want to know about heirloom seeds and what this means. And heirloom is really less about the flavor or the taste of something than it is a time signifier. And most plant breeders and plant propagators will place 1950 as the definitive year for when heirlooms stop being heirlooms and start to become modern seeds. And really just that means is in 1950, we're starting to see in America the post-World War II victory gardens, which is a popular concept these days, we start to see the rise of industrial agriculture, not family farms as much. We start to see a decline in family-owned farms, and we start to see larger scale agriculture because now food is being shipped across the country. The technology for cold refrigeration has changed. Supermarkets start to rise as opposed to community grocery stores. We also start to see the rise of suburbanization, where we have veterans coming back from abroad and need additional housing, and people want to get out of American cities. This is also the beginnings of, for those of us who live in New York City, of rent regulation and rent protection, rent stabilization, as a side note. This is also where we start to see the rise of synthetic fertilizers and chemical fertilizers. And this was just really up marketing. When you have a lot of gunpowder and ammunition that's left over from a war and you don't have a use for it anymore, and it is highly shelf unstable, meaning that it can ignite at any given time, you need to find a use for it because you just can't dump it somewhere. And so they created chemical fertilizers, namely high nitrogen fertilizers, which gave birth to the Great American Lawn, because lawns love nitrogen. And so it was a win-win, except not in the win-win when it comes to environmental sustainability, and plant-based and animal ecology. Heirloom plants are usually open pollinated, meaning that wind can pollinate them. Um, Insects can pollinate them. Other kinds of pollinators can pollinate them. I'm using the term insect in a very scientific way. But not all open pollinated varieties are heirloom, meaning that you have monitor varieties. There are people who are still breeding plants and seeds that are open pollinated. In fact, Michael Mazurek up at Cornell Cooperative Extension, who works very closely with the Stone Barns Institute for Agriculture, is a really famous New York open pollinated seed breeder, specifically for farms, small scale farms that are doing more of a biodynamic ecological approach. And today's modern varieties may become tomorrow's heirloom varieties, in that those varieties may stabilize and become standardized and may be collected for generations to come. So when we're thinking about heirlooms, I think oftentimes it is a much better approach thinking about them in terms of cultural preservation markers. Who are we trying to save seeds? Why are we trying to save seeds and why are we trying to distribute this particular kind of seed? Why are we trying to preserve this variety, this cultivar, and this species of plant? And that gets to the heart of the integrity of the plant itself. Maybe it tastes good, maybe it's rare, maybe because a part of the world that is in armed conflict right now, and armed conflict is a really great way for a plant to go extinct in one generation. Um, we may ask ourselves, where do these seeds come from and who cultivated them? And are they at risk of extinction? And a working definition that I have found fairly common around plant breeders is, um, plants are at risk in the seed trade if you can only find them in 3 or fewer seed companies carrying it at any given time. And here's the logic behind it. Seed companies are not high profit businesses unless there's intellectual property attached to them and you can control who can purchase your seed and how they use it. If one of those seed companies goes out of business and only 3 companies carry it, you've just lost 33% of the availability of that seed in the entire country. And that's a very, or if a company decides to stop carrying that seed, then that's it. You won't be able to get it unless you are going back to seed libraries and community seed libraries. And this is where the activist component, I think, is most critical in terms of food sovereignty and preservation, particularly cultural preservation around plants. So some critical seed saving definitions. And this is where it becomes very, very botany. Some big concepts, and I'm going to try to distill them down very, very small. We're talking about 2 different kinds of reproduction in plants. And these are types of production you're already familiar with as gardeners. Maybe you just didn't even realize it. We're talking about asexual reproduction and sexual reproduction. And in asexual reproduction, the outcome is the rise to clone copies of the parent plants with identical genetics, no genetic differences between parents and clones. So anyone who has ever taken a cutting before, again, those of you who grow tomatoes and you prune your tomatoes during the summer, and you root those cuttings on by sticking them in the ground or putting them in a cup of water, and then you plant them out, you have just engaged in a practice of asexual reproduction where you are taking a clone of the original parent plant with the exact same genetic characteristics and propagating it forward. Now, this can be really great in terms of sharing plants among different people and making sure that they have parent plant stock for saving seeds in different places. But it can also lead rise to a monoculture of genetic diversity because, again, the offspring of those cuttings are genetically identical to the source plant. And so where you'll get diversity going forward is in sexual reproduction, which gives rise to seed stock with genetic diversity through the combination of genetic information from 2 parents. So if I take a black crim plant started from seed and I take a black crim tomato plant started from another seed, and those 2 individuals cross coming from 2 different seeds, their outcomes in terms of the seed and the plants that will come from those seeds is genetically very different in terms of the ability to evolve than the cutting I might have taken from a black crim plant, even though the kid plants look very, very similar to the parents. It's more about the genetic diversity and the possibility of change through plant evolution. And as plant breeders, plant propagators, you're forcing the hand of genetic diversity, sometimes even in one generation in one season. There is a caveat to cross-pollination in that some plants really strongly self-pollinate, meaning that they have flowers or one flower or an entire plant with different flowers that can self-pollinate. Tomatoes are very strongly self-pollinating. Beans are very strongly pollinating. And so what it might mean that if you want to increase the genetic diversity among these crops because you want to create resilient seed stock, you might actually have to hand pollinate different plants together or create a way for a multitude of parent plants of the same variety, of the same type, of the same species to cross-pollinate each other. Where you're taking the pollen of one plant and spreading it to another. And again, self-pollination is a plant pollinating itself. Now, why does this matter? Because we might get a situation, and anyone who has ever saved seeds from brassicas like broccoli or mustard greens might have experienced something called inbreeding depression, which is a condition where plants that grow from seeds that are collected from plants where they have self-pollinated or there wasn't a strong cross-pollination. Um, you might get sickly plants that either the seeds don't germinate or the seeds are really spindly and never get tall or never go to flower, or they never turn green. And if they never turn green, they can't photosynthesize, so they can't produce their own food, so they may never get to the point of maturity to be able to produce seeds. And so this happens over the course of multiple generations, but in certain plants, you'll see this very, very strongly in the first filial generation or the F1 generation, which is the first generation after you've grown seeds out from two plants that have cross-pollinated or self-pollinated. And so the workaround to this, particularly around things that are very strongly self-pollinating or things where there's a stronger likelihood for inbreeding depression, is to cross-pollinate under genetic isolation. And this is to say that you're preventing pollen from one variety, cultivar, or species of plant from pollinating another variety, cultivar, species of plant. So if I had black crim tomatoes, again, I'm a little bit obsessed with them, but if I have black crim tomatoes and I know that I want to evolve the genetic stock of those seeds, but I know that tomatoes are very strongly self-pollinating, I might decide to take a section of my garden and build a physical cage around 20 black crim plants so they are more likely to cross-pollinate each other, but they're not going to cross-pollinate with my Paul Robeson or my green zebra tomatoes, or tomatoes or my black cherry tomatoes. So you're eliminating the possibilities of cross-pollination, but you're also encouraging it in other ways by creating some sort of physical isolation technique. And you'll oftentimes see this through caging or bagging flowers or separating things so far apart from each other where the likelihood of them crossing is much more limited. So seed processing, once you collect those seeds, there's two main ways of processing seeds, where you talk about dry processing and wet processing. And so dry processing is the more common of the two, where you're taking seeds from a dried fruit, or dry chaff, and you're using some sort of physical or mechanical technique, like threshing, or anyone who's taken or a seed pod and rubbed it over a screen and allowed the seed to fall through, or have crushed the seed pod like okra to scrape the seeds out. This is dry processing. Dry processing also leads to particular techniques around seed storage and making sure that seed stays viable while it's dormant. Wet processing is a different one in that it is what it is. You are separating seeds from wet fruit, and you are separating the seed using chemical processes that are wet, such as fermentation. And tomatoes, again, are a great example of wet processing, where you take a tomato, you crush it up. You can't really separate the pulp from the seed as easily, so what you'll often do is you'll put it in a jar of water. You'll wait for it to go fermenty and bubbly. When it starts growing mold, at that point, the fermentation has eaten away at the pulp around the seed, and you can just wash the seed clean. And why does this matter so much? Many plants that where it's required to use a wet processing technique, the fruit of the plant itself contains enzymes or growth inhibitors that prevent the germination of that seed until the enzyme is completely eliminated. So this way the seed doesn't germinate at an improper time. Like it's not the best strategy for a tomato to germinate in the fall because it likes warm season. So tomatoes are exactly like this. So if you've noticed in your garden, if you have a tomato that falls to the ground, the seeds in that tomato are not going to germinate until that tomato plant has completely, or excuse me, the fruit of that tomato has completely rotted away, because of the growth inhibitor that is preventing that seed from germinating. And this is a technique of evolution in these plants, because they've co-evolved with animals that may eat these seeds, and the pulp may be eliminated through the gastric acid, the stomach acid of these animals. And then these animals will deposit their seeds or these plant seeds wherever they go. To just say it very matter of fact, when they poop them out somewhere else. And there's a strategy in that where seeds get traveled over a longer period or a wider period, or excuse me, a wider tract of land. If you don't keep all your seeds in the same spot, if you don't figuratively put all your eggs in one basket, as an evolutionary strategy, you might do better in terms of making sure that your genetic material travels on. Uh, when we're talking about seed storage and seed propagation, we're talking mainly about two types of seeds, orthodox seeds and recalcitrant seeds or unorthodox seeds. And orthodox seeds are a type of seed that requires cool, dry germination for the seeds to remain viable. Um, to withstand a winter essentially. And most seeds that you grow in a garden are going to be orthodox seeds, which means that you can save them and store them in envelopes. Pretty much every seed that you're ordering from a seed catalog where they arrive in an envelope is going to be an orthodox seed, which means that in terms of storing them, they like it cold, they like it dry. Sometimes they require a dormancy period where they won't germinate the minute you collect them from the seed pod or from the fruit, but they might. And they may need to some sort of mimicking of winter conditions in order to germinate. A good example of this is anyone they won't germinate unless, or excuse me, they won't start growing unless they've been cold treated. Again, it's an evolutionary strategy, so seeds don't germinate at an improper time. So some things like anyone who's grown butterfly milkweed, very pretty native plant, it's the difference between having a germination rate of maybe 15% for untreated seed, uncold treated seed versus maybe 85 or 90% for cold treated seed. So basically, you have to fake the plant into thinking that it's winter. And this is sometimes called moist cold stratification. Recalcitrant seeds or unorthodox seeds are a type of seed that requires moist storage to ensure the viability of the seed. Usually there's no dormant period of the seed, and a lot of tropical seeds are like this because they come from wetter areas and environments they can't withstand drying out. They've evolved to not dry out. And so they will typically not survive cold, dry storage, but are usually ready to germinate right away. And a good everyday kitchen example of this is anyone who's grown avocado pits using toothpicks in a jar of water. These are unorthodox or recalcitrant seeds. They're ready to go right away, but they can't dry out and they can't be subjected to cold. But again, most seeds you grow in your garden or you source from a seed catalog or a community seed library will be orthodox seeds, which makes it a little bit easier. Storage questions when you're working across your community activist project around seed libraries is what are going to be the physical conditions of the storage site where the seeds are going to live? Is it dry? Is it wet? Is it humid? Are the temperatures fluctuating? Is it moldy? Is it hot? Is it cold? Are the seeds secure from animals? Are they secured from people? Because again, you want to distribute seeds, but you don't necessarily want people mixing up your seeds or introducing pathogens into a controlled environment, if that's a building or if that's a shoebox. Can the seeds stay here for a while or will they have to be relocated at some point? Is this a temporary storage solution versus a longer term storage solution? And on that note, that is the crash course on community seed libraries. This is the part where I wish you happy Earth Day and I answer some of your questions. But first, I would like to give a shout out to Highline gardener Allende Lisrap, who is a brilliant plant photographer, and he is responsible for all of the plant photography you saw in this presentation. So thank you, everyone. And going to stop sharing my screen so I can see everyone. Hi again.
Thanks, Eric. That was amazing. I really enjoyed learning so much, and I'm sure the other participants did too. I'm going to read some questions. We had 3 questions from the chat so far. So if any folks have any other questions, and in a little bit, I'll unmute the folks from the call for questions. But the first one was, maybe you did this already. Will you cover seed storage best practices for small scale operation? I think you kind of already did that, but if you wanted to add details.
I would say if you want to simplify the project, keep seeds dry, keep seeds cool. They don't necessarily have to be cold. You don't need to keep them in your refrigerator. Shoe boxes are great for them, but you just want to be able to control the variables. Your radiator, keep them someplace where they can be consistently cool and consistently dry.
Thanks, Eric. Another one is, how much space should there be between each plant to prevent cross-pollination between varieties?
Ooh, that's a good question. And in a smaller garden, it can be a lot harder to isolate in terms of distance. What I would say then, if you're trying to prevent cross-pollination, you would want to use some sort of mechanical control, a physical control. So floating row cover, so long as you can pin it down and keep insects from cross-pollinating things, you can keep things very closely together. You can also build screen cages where you just lift the cage up and then physically lower it back down if you can work quickly. There are also specialty drawstring bags where you can pollinate or flowers yourselves and then just make sure that you can just draw the drawstring over the flower itself. And then after it starts developing fruit, you can take the drawstring off and then just collect fruit, just making sure that you tag you can tie a piece of string around it to make sure that's the one where you're collecting seeds from, and then you don't have to worry about it so much. In a smaller scale, I would say you don't necessarily need to focus so much on physically isolating plants as much, but you just want to make sure that if you're collecting seeds, that you don't mix up the seeds that might have crossed versus the ones that you intentionally isolated on a single plant. But for certain things that are wind pollinated, like corn, you would probably want to have a very wide distance between them. And so in those cases, physical isolation through some sort of barrier is even more important.
Thanks, Eric. Okay, two kind of related questions about seeds. So do you bag or cage in the flower stage or before? For example, if there are turnips flowering next to collard greens, and then any tips for seed saving in humid climates?
Seed saving in humid climates. Yes. I'll start with that. Um, there's no huge difference in terms of collecting seeds in humid climates, but in terms of storage, you want to make sure that the seeds have dried out enough where they're not going to go moldy. Usually, you're bringing a seed moisture level down to about 3%. Um, and it's really hard to know this unless you're physically measuring it with scientific equipment. But for those who want to do it really, really seriously, you can pick up gel silica, those little packets that you see in shoes to keep shoes from getting too much humidity. They sell a specialty one specifically for seed growing that changes color. It'll change from orange to blue once, or typically orange to blue when all of the moisture has been extracted out from seeds, and you can store that, and then you can reuse that gel silica by resetting it by sticking it in an oven to draw out the moisture again. If you want to get that technique with it, you can also use rice in a jar. You can put envelopes inside a jar of rice to try to draw out some of the moisture. You can, so long as you create a physical distance in this scenario, you can also use table salt. You'll have to toss the table salt because eventually it'll take on the moisture from those seeds if you're introducing a lot of seeds in. But the collection of the seeds is the same. It's the storage in a humid environment. And that could also be, in New York City with less weather than necessarily deep south. you can get into mold issues in storage if seeds are improperly stored. I'm forgetting what the first part of that question was. Oh, mustards and collards and crossing, right? Flower versus later stage. I would say the ideal time is when the flower is in bud, before it opens, because the minute that flower opens, unless you're there standing watching it open, a lot of flowers actually open very early in the morning, and so you wouldn't be able to guarantee that it hadn't been cross-pollinated. What you could possibly do, though, is you can take a flower bud. It's a little trickier for smaller flowers, but you can actually tie them closed. This is the way a lot of cucurbit growers, like cucumbers, melons, etc., they'll physically tie a flower close and then wait until they're ready to untie it so they can open it up and then they can cross-pollinate selectively. And so that's another way you can think through it, is if you want to intentionally cross-pollinate things yourself. But definitely getting it before the flower bud opens is key. And that's where like those little muslin bags with the drawstring are really great, because you can just put it over the bud before it opens, and then you can just untie it when the flower opens.
Thank you so much, Eric. So we're at 5:29. We got a lot of really incredible questions later on that we will not be able to get to at this time, but I just want to leave room for maybe one more question from the folks on the call. So I'm just that are calling in. So I'm just going to unmute folks. If anyone from the call, I'm unmuting you. If you wanted to ask a question, now's your chance.
Hi.
Anybody? Yes, go ahead.
Hey.
Do you have a question for Eric? No? Okay. I don't think we have any question. Oh, yes, did you have a question? Okay, I'm just going to go back to muting folks because I don't think they had a question. So I just want to, and now we're at 5:30, we're at time, but I do have the questions here that I can email to Eric, and maybe he can provide more insight on that. We did record this session, and we will be sending out an email to that recording as well. And Eric, someone wanted to know if you could share the presentation slides.
Yeah, I'd be happy to. Would that be the easiest way to share it with you all at GreenThumb?
Yeah, you could share it with us at GreenThumb, and then I will be sending an email to folks that actually RSVP through the Eventbrite. If you did not RSVP through the Eventbrite, I'm just typing out my email here that you can email me with that. And I just wanted to say thank you so much to Eric for such a fascinating, incredible workshop that we've learned so much over this past hour on Earth Day. Thank you again for wrapping up our GreenThumb virtual workshops.